Lee, and I will be the moderator for this webinar. I'm excited to be joined today by Mark Romano, who is the Geospatial Senior Product Manager at Harris Corporation. Mark has an extensive background, 20-plus years, leading innovative remote sensing technology, hardware, and software development. At Harris, he's currently responsible for developing new technologies to provide added value with LiDAR and other geospatial technologies for both federal and commercial sectors. We also have Randy Rhodes here today to help answer any questions at the end of the presentation. Randy is the Geospatial Utility Manager at Harris and has been applying LiDAR and other geospatial technologies to solve challenges specifically within the electrical utility industry over the past 15 years. During the presentation today, Mark will discuss how Geiger-mode LiDAR enables the utility industry to use data from a single acquisition to develop solutions for both transmission and distribution networks for asset management, vegetation management, engineering, and more. I've muted the phone lines for all attendees, so if you have any questions at any point during the webinar, feel free to enter them into the questions chat box, and Mark and Randy will try to answer as many as they can at the end of the presentation. I'd also like to mention that we'll have a recording of this webinar. It will be emailed to you in the next 24 hours. And now I'm going to turn things over to Mark.
Hi, good afternoon, everyone. Pleasure to be here. So we're going to talk about vegetation encroachment, utilities, and with respect to utilities, specifically how we use Geiger-mode LiDAR to solve these problems, as well as just overall program management of utility assets and infrastructure. So just a really quick background on Harris. I'm not going to dive deep here. If you don't know Harris, we're a large aerospace and engineering company with over 9,000 engineers, offices throughout the world. The geospatial group at Harris is actually over 20 years old. A lot of people didn't know us in the commercial sector. About 2 years ago, Harris developed or started the Commercial Geospatial Solutions Group, and in that time period also acquired Axelis Corp, which brought us a lot of remote sensing technology for those familiar with NV LiDAR, and some of the analytics that we can also do. So we have a very strong background in both geospatial collection and production and analytics as a combined group now, which has been, again, developed this new business unit called the Harris Commercial Geospatial Solutions Group. So just a little bit for those that are and are not familiar with utilities and LiDAR. Back in 03, the first sort of NERC reports came out and mandates, which were caused by a major power grid failure. NERC itself, which is the North American Electric Reliability Corporation, mandates a lot of the work that we do today for utilities, utilizing LiDAR, imagery, surveying, mapping, and a lot of geospatial technology. Initially, transmission was the focus to comply with safety and operational challenges for the critical infrastructure. 9/11 also played a big role in this now becoming really a government concern from a security standpoint. And so as time has gone on, those mandates have expanded. Again, primarily we were focused on the transmission side of the business, and today we're going to talk a lot more about the distribution side of the business and also comprehensive asset management and other aspects of the business. So first of all, where have we used LiDAR in the utility industry? Back in the mid to late 90s, when LiDAR itself came on the scene, the utility companies were actually one of the very first to really utilize what I'd call all of the point cloud. While the rest of the world was focused on creating contour maps and terrain models, the utility industry really saw early benefit in the ability to extract assets such as poles and wires and substations and other critical elements of their business, and also do things like, vegetation management, as-built, modeling, etc. So that business over time has really expanded for those that have utilized LiDAR in the operations of a utility business and all the different types of products that we can deliver today. So it really does answer the mail on a large majority of the problem sets that utilities face. Coupled with optical imagery, it really has done a lot to change how utilities manage their businesses today. So how does Geiger-mode help? Geiger-mode LiDAR is a wide area, very high-speed collection and high-resolution platform. So whereas utilities in the past, 15 years have utilized LiDAR to a great extent, we've all had to fly corridors at very low altitudes, at very low speeds to get these types of resolutions. So what you're looking at on the screen here is a collection that was done at 17,000 feet above the ground, and it's still preserving that high density, high resolution point cloud that we use to extract the utility assets and information and create analytics. This is another example of just a distribution line, again flown at a very high altitude, so we can collect very broad areas of the land cover and still perform the similar tasks that we can perform with normally what are done as low altitude flights. So I'm going to do a little bit of Geiger-mode 101. If you have detailed questions, we'll definitely answer them at the end, or if they get really detailed, we can take those offline and get you the information that you need. But what's interesting about Geiger-mode LiDAR is, again, we can collect very wide swaths of information at very high speeds. We're typically flying today at around 250 knots with a swath width of 3 to 5 miles wide, and we're getting 30 to 50 points per meter resolution, which is really the sort of requirement space, if you will, for what utilities need to get the level of detail that they need to extract their infrastructure. So if you think about traditional LiDAR systems, we call them a spinning dot technology or linear mode technology. It really is a single beam system, either a bidirectional scan pattern like you see here, or a spinning dot where it's a spinning polygonal mirror. And it's a very high power, low sensitivity system. So we put a lot of power into very small beam footprint, and we collect the area one time as we're scanning across the scene. The Geiger-mode system, you can really think of it as a camera, because that's what it is. It's a very fancy camera. And we're illuminating a large area of the ground, as you can see in the graphic, and we're actually capturing a set of pixels, or in this case, a set of elevation pixels from each footprint. So as it scans around, it's actually a Palmer or circular scanning system, and you can see on the right just one little slice of one scan from the system. So it collects information very differently, and it also over-collects, if you will, because these footprints that you see on the left-hand side actually have overlap. So we look at the same feature multiple times. When we collect the data, we also fly it in two different directions. So we're collecting on the fore and the aft of each circle. So where you get a lot of obscuration with linear systems, because you're only hitting them one time from one angle, we're actually capturing them hundreds of times from multiple angles. So we fill in a lot of the obscure features you might otherwise have unless you fly over something multiple times with a typical LiDAR system. And this is just an example of a scene of the exact same object, and you can see on the left the scan pattern, if you will, from a linear system, again, that only visits that object one time as the beam hits it, whereas we provide an aggregate of multiple measurements to create an elevation scene. There's been a lot of discussion in industry about whether Geiger-mode LiDAR works in foliage environments because it's not a multi-return system. This is an example again in Florida showing you, very thick mangrove swamp, and you can see, excellent foliage penetration, a lot of points on the ground. And we can really derive very high-resolution terrain data, wires, poles, building other infrastructure. So again, this was flown at 17,000 feet, not 1,000 feet off the ground. So that's just a little bit about LiDAR. I'm going to get into talking about types of solutions now we use to produce utility data sets and how utilities use the information. So a typical utility project, if you've done LiDAR projects before, requires, and this is specifically about critical conductor distances, so distances to vegetation or to man-made objects. The classification scheme, this is how you might set a project up, and these vary by utility, but they're all similar in nature. What types of assets are you going to extract? What type of analysis are you going to perform? In the upper side, you can kind of see the different layers that we're going to classify the point cloud into, and in the bottom section, 22 through 28. These are the distances from the conductors based on different voltages the utilities will give you in terms of setting up your project when we start looking at the vegetation encroachment part of the process. So the first thing that we do is we actually classify all the data into logical subsets. And when I say that, so we're trying to we obviously need to make measurements to ground. We need to understand tree heights. And we need to understand tree heights so that we can apply the right remediation or treatment after we analyze the data. So utility companies need to understand, when I'm trying to clear my right-of-way of vegetation, am I needing a brush hog, a chainsaw, a bucket truck? Is herbicide going to answer the bell? So we break this, and again, these are set up by the utility companies. They will tell us, what are their critical layers in terms of how they clear their right-of-ways. After we've done the initial classification, we go in and we actually extract the poles and wires, and we create simple models. We create vectors of all of those. And then we go in and actually classify the lines, the static wires, the overbuild, the underbuild, the poles, all by phase and type. And again, this is part of that initial schema that you work with the utility company to derive as part of your project schema before you start processing. At this stage as well, if you're doing PLS CAD modeling to do uprating or modeling and analysis of your existing right-of-way, once you have all these points classified, they can be consumed into PLS CAD for the engineering side of the business. Once we have the vector data, we can now do the vegetation clearance or distances from the wire. And in this case here, we're actually talking about distribution. In transmission, they typically clear the entire right-of-way. In distribution, it's not quite so simple. When you go through a neighborhood, you can't just clear all the trees off of a landowner's or your cities and parks area. So we can't be quite as abrupt about how we clear vegetation. In other words, we're not going to completely cut that tree down on the left-hand side, so that we'll typically hollow those out, or depending on the area and where it's going through. If it's rural and it's not going through a neighborhood, they might deal with it a different way than they would in a neighborhood area where people aren't going to be as friendly about the fact that you're going to cut their trees down. And what you see here is kind of like a bullseye, but basically those are those distances I was showing you earlier. And the utility has what they would call a very minimum distance, where it's a hazard, essentially. The tree could either fall, touch, arc the wire, and shut the system down. And then they'll give different, again, each utility has different different distances based on their voltages that they're going to require you to do this type of management with. And they might clear it all the way back to the purple circle, for instance, in the middle, which might buy them more time over years of growth. Once you've got all the extractions done, we analyze the entire network. So this becomes an automated process at this point, and it'll run the entire network. Once you've done that analysis, and what you can see in the lower left-hand corner is actually different polygons that are built from the interference points that were used to classify the vegetation. And again, those are those different distances that they can clear that out to, but they're also going to consider how they're going to clear it. So at this point, they start taking things into account like the slope of the land. Even if I have to use a bucket truck, can the bucket truck reach both sides of it? What does the density of that look like per span? Because when the utilities do actually remediate, they do it by span. So this, at this point, really becomes a GIS-enabled base map, which field crews and others can use to go out in the field and manage their infrastructure. Once you have all that, this really does become very prescriptive in how you're going to treat it. So again, what you're looking at here are colored by span, and it shows, you know, the least ingress egress versus the most problematic. We can also, at this point, because it's in a GIS, we can incorporate other things like, you know, street access, right-of-way access, ownership. Cluttered environments are really important, especially if you've got to get a truck in there in terms of things like wires, signs, guardrails, dumpsters. All of those affect how they're going to be able to actually go in and do that work. Terrain is also a very important component, even though it might look like you can get a truck in there if the slope is too great. And again, they'll give us a slope criteria or maximum on that. It might look like you can get a truck in there, but you might not actually be able to get a truck in there to perform the work. So this breaks it into logical pieces in terms of what assets are they going to need to go out there and perform that work. Once you've got all this information in the GIS, the utility companies have an enormous amount of information, but most of that information is pretty old, and a lot of the information they have today that relates to their infrastructure was actually conflated back in the day from paper maps. So a lot of the information, while it is highly valuable, is not geolocated in a way that they can use it. So in this step, we go through a conflation process where all that infrastructure information is actually conflated or correlated back to the real asset locations. And there's also been a lot of change in this infrastructure over many years. So once we have all the poles and wires, we can get right down now to, once conflated, even the actual tower itself, what it's made out of, what its materials are, what types of insulators, what types of cross arms, nuts, bolts, etc. And you can really create a very useful set of information once you can conflate all that information in. The other thing that this does at that point is, and this is a very big part of the conflation, is most of the utilities today are using Small World as what we'd call their central database. And so once we go through conflation, everything is enabled inside the Small World environment, and it's actually basically a GeoHub that can talk to Maximo, Clarion, Esri, and so forth. So this gives all of the what we call today's different markets within the utility or stovepipes within the utility the ability to all look at the same information from a central repository and still use the same tools they do their work with today. The last step is comprehensive pole inspection. So this is where we get down now, and we've located our assets. We've got our inventory of all the materials and nuts, bolts that those assets are comprised of, and now we can go and inspect the condition of those assets. We can create yet another layer that is very strategic in terms of how they're going, or when and where are they going to perform work, and what's the most important work they need to perform. And this is typically done today from either ground inspections, aerial, low altitude aerial oblique collections with imagers, and now we're starting to see migration into the UAV space in terms of UAV images. But again, you're creating another layer of information that allows them to better prescribe their work. And this is where you can really get down to the insulator. You know, is an insulator cracked? Is a bolt rusted? Is a wire broken? Or is a wire failing? Is there woodpecker damage? And that list goes on and on. And utility companies have a very extensive list. You know, there's pages and pages of inspection reports for each type of tower or pole. When this is done in this fashion, again, this becomes another layer of geo-enabled data. So once we perform the inspection and meet and fill out the criteria, the inspection criteria list, then the engineer or the work management person within the utility can go in, pull that information up, look at that inspection report, and inspect those defects, and go out with basically the parts list to repair the asset. But they can also sort those assets by their level of severity, so they know how to focus their workloads, their work efforts better. So to summarize, once you have all this information, and this is no small task, and utilities are just starting to migrate now from transmission all the way down to the distribution side and look at this from an entire network standpoint. You really, at the end of the day, have a really interoperable system. You have a real asset management system where you can do budgetary estimating. You can perform all types of analytics. You can focus your pole repairs, your vegetation management, your engineering level work. And once you have all this information and you know where the weak links are, or the most, you know, where the least reliable parts of the networks are, in an emergency scenario such as, you know, a hurricane or a flood situation, etc., you can better determine when that storm event is going to occur, where are the most probable places you're going to have issues, and where to place your assets. And in this case, a utility, if you've worked with them in the past, and there's a hurricane approaching the state of Florida, for example, they're launching thousands of people on the ground, pre-positioning them for what might be. And they don't have this level of knowledge today to be able to have, you know, a better impact on how they're going to manage that outage. So we can't do real-time prediction yet, but with knowledge of the weakest links in the network and the system, and also the number of customers or emergency services that are going to be affected, they're going to have a lot more knowledge on how to position those types of responders. And then secondly, post-event is to go back out and what we call reharden or baseline the entire network. Because you've got an as-built, you know what it was, you know, pre-storm event, and you know it's affected, then you can go out and recollect and again reposition the way you're going to respond to that event over time. In 72 hours, which is the pretty typical time frame, they're going to get the power back on, but there's still a lot of work to be done for months to come after that. And how they budget for that and how they address that and in what order is what this is really going to enable them to more accurately do. So from that, I just had a quick poll question, or a couple of quick poll questions for the audience, and then we can start addressing some of your questions. So the first question is basically, have you used LiDAR before? And I'll give you a minute to answer that if you don't mind. Well, it looks like 86% of you have used it before, so that's great. Now I'm trying to figure out how to use this thing. I apologize. How to get on to the next question. There we go. The next question is, if yes, what applications have you used it for? Fantastic. So it looks like it's about a 50-50 split between vegetation management and engineering analysis, and 35% for asset management, and I see 63% voted with GIS and IT, and 40% other. I'm not sure how that gets us to 100%, but all right.
They were able to collect all that applied, so they're using it for several different applications, I think.
Gotcha.
Right. Great. Thank you, Mark, for the informative presentation. At this point, Mark and Randy will address some of the questions that have come in. So you're welcome to put in your questions in that questions chat box, or the questions box of your GoToWebinar. So one of the first questions is, what's the accuracy of Geiger?
Okay. So Geiger mode today, if you're talking about absolute accuracy, that's, relative to survey control coordinates, and, it's anywhere from 5 to 10 centimeters. The precision within the data itself is going to be typically better than 5 centimeters.
Great. How does Harris sell or intend to sell the GM LiDAR sensors, or just provide the services?
Yeah, we're not in the sensor manufacturing business. We do build these for our own use, and we actually have worldwide partners that actually utilize the technology, but we're not intending to be in the sensor manufacturing business.
Great. How many GM LiDAR sensors does Harris have, and are there others in the world or the U.S.?
So currently we have 3. There's a 4th slated to be built this year to start moving further into the foreign markets. There are no other Geiger mode LiDAR sensors today in the commercial sector. There are various ones in the defense sector that we've actually been involved with for about the last 16 years, but not for the commercial side of the business.
Great. What is the turnaround time between post-storm airborne survey and delivery of a new baseline database for asset management?
Well, that's a really good question. And that would very much depend, obviously, on the size of the area. I can give you an idea of what the throughput rate is of our existing sensor and what the throughput rate of our infrastructure is. So we can collect at this resolution about 1,000 square miles per, I think it's about a 4-hour mission, 3 to 4 hour mission.
Right.
So one sortie or one lift in the airplane can get us about 1,000 square miles currently. We are looking at other platforms such as jets right now where we could stay aloft longer, but that's about the collection rate to get this type of resolution, and especially in vegetated environments where we've got to get through the trees a lot. Our processing rate in-house here, because this is not a desktop solution, this is actually done across an enterprise grid with thousands of cores, is currently in-house about 1,000 miles per day rate, and we are also enabling our grid infrastructure up in the cloud, the Amazon cloud right now, which will allow us to scale that at an even higher throughput rate. So we can basically come out with a processed point cloud today at about 1,000 miles per day rate.
And in general terms, assuming weather allows and the areas within those parameters, it's going to take, I think the best mark we looked at was about 48 hours was the best turnaround of a product back. I don't think we'd get within 24, and it's most likely that if it fits within those parameters, somewhere in that 48 to 72 is the best you'll see from the Geiger mode side.
Yeah, and I would agree with that. And also that supposes that we already have the infrastructure. So, for example, if we wanted to go assess, vegetation or other encroachments post-storm, as long as we already have the baseline data, i.e. the poles and wires sets developed in our baseline, then it is very automated to go and rerun the vegetation clearances in our system, because that is fully within the enterprise. That's all done automatically once we have the base assets extracted.
Great. So how does your survey technology, client delivery platform, and asset metrics compare to Fergro Rome's? I don't know if I said that right.
Well, I don't think we're here to talk about other customer comparisons, so I will decline that comment.
And maybe you already answered this one, but let's see. I think you already answered this, but does Harris manage the Geiger LiDAR for customers in cloud or deliver LAS files to customers?
So we do both. So we deliver, standard LAS format data and other formats of data, but we can essentially feed data into any type of platform. For example, our derivative products end up in databases such as Small World or Esri. Our point clouds can be really delivered as in any type system, including PLS CAD if you're talking about the utility space. So there's really no constraint on how we deliver data. In terms of enterprise, we do host data as well for our customers and delivery systems to our customers. So we've got clients already that all their data is hosted, and within their organization, they can constrain things like security permissions and who has access to what and so forth. But we're making a big we're forging rapidly into the cloud because a lot of people are trying to start outsourcing their data management and also hosting of that data because it is a lot of big data. What was interesting for us is that, big data in the eyes of most is a lot of transactions. This is big data in terms of volume. These are really huge files. So it's a little bit different when you use that term, but yes, we can host data at pretty much any level to customers.
Okay, and along those lines, is there a large like public available sample database available for the public?
So not yet. We are close to launching, and I expect within the next 2 months you'll see some announcements on what I'd call our repository of data. We are developing a new e-commerce portal. We acquired another company about 1.5 years ago called MapMart. We're having to expand the infrastructure there to be able to house this much data. And we're also working with Amazon to store it there so it can be retrieved, but soon there will be a place where you can go and get samples or even purchase online various resolutions and types of data. There'll be everything there from image content to LiDAR content to feature content. Today, if anybody in the audience needs to get access to sample data, you can actually email me directly and I can facilitate you getting some data if that's what you're interested in.
Great. Is your classification also automated?
Yes, it is. So again, everything we do is on our grid system. So when a data set comes out of, and this is where it gets a little deeper into the LiDAR beyond the 101, but all of our data is fed directly in from the aircraft into our enterprise, and it goes through a registration and calibration and a classification process. So when the data comes out the back end, it's actually fully classified and ready to use.
And I'll make a caveat to that, Mark. It will depend on the features they want extracted from the data set. In other words, you can have intelligent extraction. We work together with different partners. You probably saw them in there. It's semi-automated because although it'll extract all the poles and wires, but they may not all be the poles and wires of the client system. They may be different systems that cross within their territory. So there is a bit of QA/QC that goes into that to understand what's needed by the client.
Yeah, for example, we're not extracting poles and wires automatically, but the base classifications such as terrains or vegetation height or strata, buildings, simple infrastructure, that's highly automated today. Poles and wires are where we're investing large bets on things like deep learning to start solving these problems, these more fine detail or infrastructure problems more automatically. So that is definitely not there.
A lot of the machine learning is doing that, right?
Yep.
The next question is the assets management issue. Does it include monitoring resting pollution on insulators?
Rust and pollution?
Monitoring resting pollution.
Yes.
Does that not make sense?
Yeah. When we go through a pole inspection, I don't have a list in front of me here, but the utility company themselves, I can't name names here, but I mean when we do comprehensive pole inspection, there's a huge list of things that we have to inspect, and it's literally right down to the nuts and the bolts and the rust and the woodpeckers and the cracked insulators and on and on. So all of those things are inspected to the utilities standard or schema that they give us that we have to fill out, and that is provided back to the customer so that they can take action on those types of assets. And again, remember, if we go through the conflation task that we discussed earlier, they even know the assets, or at least can verify the assets are the right assets that they have in their engineering drawings. So when we're all said and done, they actually know the parts list, to go out and actually affect or remediate the problems as well.
Right, and again, on a furthering of that, that isn't necessarily from the LiDAR, as Mark says. That's just part of the full solution with the partners to go to the imagery. And Mark brought it up. It's that imagery may be captured from low altitude. It may be captured from the ground. It may also be captured from UAV in different cases. But that is all part of the full comprehensive inspection basis to get that information out of it.
Correct.
Is the product coverage in Alberta?
We do not have any coverage in Alberta.
Not currently, no.
We actually do have, they're not utility projects currently, but we do have forestry projects that will be starting there next year.
Yeah. And a great part of this, as Mark mentioned, it's being able to repurpose the data. We may be flying for a city or a province or a state or a county, but being able to reprocess that data and then being able to repurpose it for the utility, the highway, the forestry. In this case, we're flying for forestry. We can extract out poles and wires and be able to provide information to the utility. So there's a win-win on a financial basis for both groups.
Correct.
The next question, what type of data would be needed to identify infrastructure for feature extractions? Looking forward to additional processing of a GM collect. So what type of data would be needed to identify infrastructure for feature extractions?
Right. A lot of that's determined on a client-specific basis as to what they want to get out of it and what their project applications happen to be. It depends if they just want, for instance, a group that just wants asset location correction of poles and wires within their network, identification of numbers of complete numbers of poles within the distribution network, for instance. Things like that are going to be determined by the client as to what they want out of the product. And that's how we determine what features are going to be extracted based on the requirements from the client side.
But as far as the technology, I mean, with LiDAR, you can get down to the distribution pole and wire level. I can't do comprehensive pole inspection without imagery. But you can extract just about any asset in terms of its location, or its, if it's an object like a building, you can extract a building, a complex building model, or streets and sidewalks, or driveways, or utilities, or other infrastructure features. So the level of detail is in the LiDAR, but I can't tell you the condition of it from the LiDAR.
Right. You can see there's a transformer on a pole, or a light, or a switch to that matter. You can't see if it's a normally open switch or normally closed. You can't see that transformer actually is a bottom feed as opposed to top. Things like that just aren't decipherable within the LiDAR data itself, or the condition, as Mark pointed out.
Correct.
Next question, we've heard that the USGS said the initial GM LiDAR sensors had vegetation penetration limitations in the earlier tests. Has this been addressed, and how?
Well, that's a bit of a long story, but yeah, it does penetrate vegetation extremely well. It will outperform any existing system at any given altitude. I did show a slide earlier. I don't know if you saw that, but we are doing enormous tracts of land in subtropical environments, Florida specifically, where there's no leaf off, there's always foliage, and we're getting very high detail through canopies. We're also doing some work up in the Northwest, which is a different type of land cover, but we're getting excellent foliage penetration. And again, if anybody wants to get a sample of this data or get additional information, feel free to contact me. I'll be happy to provide you either with data or additional information on that topic. That was a very early, actually the first flight of the first system. And that test, by the way, was not for foliage penetration, it was for accuracy. So we're doing real projects all across the United States, mapping terrain in many, many different types of land cover environments very effectively.
And it's a good question, a very valid question. The one thing we have addressed it. Our sensors have all been upgraded. Our flight characteristics have addressed that, and now we're getting great products out. Mark, can you change your slide so that it shows the contact information so people can take it down so they can get in touch with you for those data samples?
Are you not seeing my last slide?
We're seeing the poll
I think we need to
response.
close that poll or hide the poll.
All right. Does that work?
Much better. Love seeing your smiling face. Great picture, by the way.
Okay, so next question, how does Geiger LiDAR handle reflective surfaces and deal with
Hello?
Jody, I didn't catch the second part of that. I heard, how does it deal with reflective
so how does
surfaces?
Geiger LiDAR handle reflective surfaces? And then how do they deal with solar background issues?
Sure. So reflective surfaces, I think what the question is probably low reflective surfaces, but I'm not sure the context of the question. But again, we're working in multiple environments. We don't have issues with, reflectivity from objects. Again, you'd have to look at real data, I guess, to prove that to yourself. But I mean, we're doing everything that we've been doing for the last 20 years with conventional LiDAR with this system. In terms of solar noise, there is reduced performance in daytime environments, so we typically do fly at night, but it just means that we have to fly a little bit lower to deal with solar noise with the sensor, but it is effective in both environments.
And we just recently flew some daytime characterization tests, and when I say that, I mean within the last couple of weeks for some different projects and clients we were working on. So they are ongoing. We just lose 10, 15% in flying height to account for the additional solar noise that happens to be in the atmosphere.
Correct. And we actually have plans very soon to include an aerial camera with our LiDAR collection platform. So we will be flying a lot of daytime missions as well. Night's always better, regardless of your sensor. Air's smoother, solar noise is non-existent, so there's benefits to flying at night, but we can do both.
Okay, so the next question, does your company do wide area collection or primarily utility corridors?
Well, we actually don't collect utility corridors. We do them as wide area collections. Again, because of the way the sensor works, we can collect very wide swath, very fast, and collect very large areas. So we go in and carve out the utility corridors to do the extractions. And we can also, as Randy was suggesting earlier, repurpose that data. So if I go fly a state, I could go ahead and extract all the utility corridors out of that area. So this is, again, fly once and use for many is sort of our motto, if you will. And we can get really high resolution from that data.
Great. So with that, we're going to wrap things up here. We appreciate everyone's attention on the line, and thank you again, Mark and Randy. If we didn't get to your question, then either Mark or Randy will follow up with you. Just a reminder, we will have a recording emailed to you in the next 24 hours, and it will also be available on our website at www.harrisgeospatial.com by tomorrow, and we encourage you to share it with your colleagues. So thank you, everyone, and have a great rest of the day.
Thank you very much.
Thank you, Jody. Thank you, Mark. Thanks, everyone. Cheers.